Everyone knows that custom water cooling is expensive. But have you seen the price of top brand all-in-one coolers these days? They're not cheap either. Which got us thinking, like the smartest bears and the dumbest humans, could there be an overlap between pricey AIOs and the most affordable custom loops? As it turns out, yes. Yes, there is. Thanks to affordable Chinese water cooling brands, you can get all of the benefits of a custom loop: upgradability, better performance, superior aesthetics, and a perfect fit for your system for less than a top-of-the-line AIO. But Linus, you might say, water cooling is hard. And you know what? That is a valid concern. How do you know which block fits your CPU, which pump is reliable, what tubing you should buy? And those are just the basics. As a first timer, how do you ensure that you have the right connectors, for instance? Well, as it turns out, Bykski has the answer. Through their reseller network, they will get rid of all the guesswork by configuring a custom water cooling setup tailor-made for your build. And we were able to cool both our CPU and our GPU for less than the price of a premium AIO. Now, I just have to build it and see if this is something that I could actually recommend, because not every experience I've had with Bykski has been smooth. Smooth, like this segue to our sponsor.
Meter. They provide enterprise full-stack networking infrastructure, whether that's for internet, wired, wireless, or cellular. They'll help you every step of the way. Check out the link in the description below.
We were shocked when we saw this Bykski custom water cooling kit for just $230 earlier this year. Like everything else, the price has gone up a little bit now, both for the parts and for shipping and tariffs from China, but still, that's a steal when you consider that it includes everything for a full hardline build, including our CPU and GPU Waterblock. That's where the real value is here, in my opinion. Because while you can spend $250+ on an AIO, there are good options from reputable brands for as little as $50 or $60. But if you want to cool your GPU, which is the one that's more likely to give you a real performance difference, then this is where the party's at. With all of that said, nothing that I've looked at so far has eased any of my concerns about difficulty. This is supposedly Bykski's beginner kit, and it still came with addressable RGB everything, which is going to make wiring more challenging, and hardline tubing. That means we're going to need a few things that the kit doesn't come with. One of these silicone tubey bendy inserts, a deburring tool, a heat gun, and some way to cut our tubes. This is a little overkill for most people. Any fine-toothed saw will do, but a bandsaw can be a real time saver. Now with that out of the way, I was gonna show you the rest of the Bykski gear, but I just noticed I have to build the computer, not just water cool it. All right, fine, no, yeah, that's fine, I can build computers. No, I got it.
I can help with that.
That would actually be great. Do you want to start getting the case going?
Yeah, I can do that.
All right, perfect. The system's not really the star of the show, but we do have to have a machine that would be worth spending the money on water cooling. So we've gone with a 9800X3D with 32 gigs of DDR5 6000 megatransfer per second memory and an RTX 4070 Ti Super GPU. We chose this for a couple of reasons, both to illustrate how it can actually be easier to get water cooling on obscure GPUs if you go full custom. AIO GPU coolers are few and far between. And then number two is to illustrate how, yeah, even with a last generation system, this can be a relatively affordable way to breathe new life into it. The other reason we went 40 series is that at the time of configuring this system, it was the last generation of NVIDIA cards to support reading the hotspot temperature on the GPU die. 50 series have since had that added, but it's a really important thing to track for longevity and thermal throttling, and water cooling helps with it a lot. Let's get this thing stripped down. This will almost certainly be the most nerve-wracking part for first timers, but if you follow some simple rules, it's pretty hard to screw up. First, keep track of where you take screws out of. You can see that I'm using the built-in magnetic parts tray in our Precision Pro screwdriver set, and I'm putting the screws in the same physical locations that they're coming out of on the back of my GPU. Another is go slow, but also don't worry too much. You know those little warranty void if removed stickers? You can see ASUS doesn't even bother putting warranty void if removed on this one anymore. In many jurisdictions, those have been found to be unenforceable. So if for whatever reason something does go wrong with your GPU that wasn't caused by your modification, it shouldn't be a huge issue to seek a warranty replacement. There we go. This always takes a little more force than I like applying to graphics cards. Now, on the subject of if you ever need to put things back, a great way to not lose track of any of these thermal pads is to keep everything together. So we're gonna go ahead and we're gonna peel these off as carefully, perfectly as we can, and we're gonna put them back on the air cooler. They don't have to stay completely perfect, just kind of do your best, okay? Now that the pads are in place, we're gonna check our GPU block to see if it includes its own backplate. If it does, we're gonna take this one off. Now it's time to be a good boy and put all my screws back where they went, no matter how excited I am to put on my new GPU Waterblock. I actually do not use any solvent for my first pass of wiping up thermal compound. I found that a lot of the time it can just cause it to smear around more. You don't have to baby the thing, but don't force anything either. Oh yeah, she's shiny. Now for the least pleasant thing about using a Bykski Waterblock. There's a bunch of thermal pads. Good luck! To figure out where the thermal pads need to go, you'll need to use a little bit of guess and check. For starters, anywhere with a little raised square, 100% gonna need a thermal pad. The only question is, are we gonna need any in these grooves? And we can check that by simply lining up the block and seeing if there's anything that touches those spots. In this case, the answer is no. So we can go ahead and start cutting our pads. Very important, don't miss the peels on both sides of these thermal pads.
So why are you putting them on the board instead of where they're marked on the block itself?
Just because these two spots on the block were longer than the components that they went on, and I cut one of my first ones a little bit too short and I wasn't sure if it would fit. And so to make sure that it's lined up properly with the components, which it does cover, I didn't want to put it randomly on here and risk leaving one uncovered. When it comes time to sanity check your thermal interfaces, I am a huge fan of counting, because not everyone knows a die from a capacitor from a resistor, but everyone knows numbers. So I've got 1, 2, 3, 4, 5, 6, 7, 8 points that I have to contact, and I've got 1, 2, 3, 4, 5, 6, 7, oh, I forgot something. 8 things that need thermal interface. For the last one though, I am not going to be using a pad. Instead, I'm going to be using a paste, and we're just going to go ahead and use the stuff that was included from Bykski. Now technically, I don't need to spread out this thermal paste, but on a bare die application, I do tend to prefer it just because missing a spot is way more detrimental here than it is when you put it on a heat spreader. I mean, it's right in the name. Heat spreaders spread out the heat. This has no heat spreader. So if there's any point in this die that we're not making contact with, big trouble. Now from experience, I know that as bad as that looks, it is gonna spread out okay. But if you don't have that experience, the easiest way to check is just to put it on, mash it down, pull it up, and see if there's any gaps. See? So with a little more pressure and a little bit of heat, that is going to be fine, just fine. Now we just gotta put on some screws, and once again, Bykski just gives you a bucket of screws and says good luck. The easiest way to tell if a screw hole is going to require one of these springs is if it has a much wider protective pad around it where there's no traces. That's there to accommodate the spring in addition to the screw head. As for the rest of the brackets, I'm just going to use these included washers and put in screws that fit like they should. Oh crap, I forgot the back plate. Now the stock back plate actually had some thermal pads on it now that I think about it. Well, one moment, please. So I'm definitely finding the deeper I go, the more not that beginner this beginner water cooling set is, but you still can't argue with the value. The entire kit cost less than this block to buy on its own. So clearly Bykski is doing some kind of subsidization for these full kits. Well, I don't know what they were trying to do with these thermal pads. It seems like it's extra cooling for the VRAM, but then these two don't have any. And I'm way less worried about the temperature of our VRAM anyway, because we've got water cooling on the front of it. So one thing that I would throw a bit of extra cooling on, not because you necessarily have to, but because it can't hurt, is this area of the PCB right where the 12-volt connector is. NVIDIA's 50 and 40 series cards have a bit of a reputation for this connector not always staying alive. And there it is. A lot more work than buying a pre-water cooled thing, but a handsome GPU, worth the effort, I would say. With this out of the way, everything else is relatively easy. I mean, here, the CPU block is going to be as simple as taking off the peel on the bottom, throwing on some thermal compound, orienting the block correctly, and here it's time for a tech tip. All you got to do, if they aren't labeled, which, thank you Bykski, they aren't, is look at what the fluid path will be inside the block. Here we can see that it's going to need to go in here, because that's going to go right down to the middle of the block and get accelerated right over the center of our CPU die. Then it's going to go through these fins, and come out this one. In, out. This is going to matter because when we're running all of our tubes later, this orientation might make it easier to do a tidy run, one weight versus the other. Now we just grab a thumb screw, a spring, and a washer, and go to town. Let's go ahead and plug in our ARGB, and with that done, it's time, if you've got one, to have a friend come and help, because there's going to be a lot of tubing to bend. While Pankratz is getting some of our wiring done, I want to talk through our loop order planning. Just like with the CPU block, our GPU block has a particular orientation that is ideal. So our inlet is here and our outlet is here. But Bykski gives us the flexibility to either come in this side or this side, and same goes for the outlet. So what we're going to do is we're going to kind of throw this in here a little bit and have a think. But before we think too much, we should probably take a look at some of our other components. We're using a triple radiator, so this is 3 by 120 millimeter. And for our reservoir pump, ooh, this looks a lot nicer than what I expected. However, I have no idea what the quality is. What the devil is a CT60? Okay, well, hopefully it's good. As for the mounting for this, we've got a number of options actually. It includes a couple of these clamps. So we would just find some holes in our case. Actually, on Fantex cases, sometimes you get these little plastic slidey cable management doodads. These are a great thing to just drill through with any cheap rotary tool and make a little mount on. Or included in our kit for our convenience is a fairly bent 120 millimeter adapter. So the idea is you would take any 120 millimeter fan in your system, mount this to it, and then mount your pump to that. This isn't going to work for two reasons. One, it's bent, but we could fix that. There we go. Two, my front fans are 140 millimeter. So we're going to have to get a little bit more creative. In addition to not using a D5 pump, this doesn't have a ton of flexibility in terms of inlets and outlets. It goes out here, and only here, and goes in up here. This is going to go here. It's going to go out to our inlet here, which is going to go out to our inlet here, which is going to go out to, the radiator's actually agnostic, it doesn't care. So it'll go in here, and this will come down here. Or it'll go this way and that way, one of the two. Okay, that's not too bad.
Am I the only one who is sketched out that all of these are exposed?
I mean, it's probably fine.
The only place I can think about actually sticking this to is on the inside of this swinging door.
This
Yes.
is going to need so much slag.
No, we could go back to the socket.
And with water cooling, our CPU won't get as hot, so it's less likely to make the adhesive go. I'm not saying it won't happen, I'm just saying it's less likely. Ah! Kidding.
This is not going to be pretty back here, but we've got panels to hide everything.
I'm gonna say the same thing about what I'm doing. I ended up having to put a nut on these because the screws were a bit too long, so... And I think I just cross-threaded that, but it's on there. You gotta be kidding me right now. I think this is gonna interfere. Oh, ball sack. New plan, we're going all the way through. So now what we're gonna do is I'm gonna put this into place. Remember kids, anything's a self-tapper if you push hard enough. One really important tech tip if you're doing this at home is if you're drilling anything in your case or doing anything that's gonna create metal shards, do it before you put your hardware in.
It's pretty much tight.
Oh yeah, that's not going anywhere. Snug as a bug in a rug, look at that, nice! And all thanks to the new nuclear colorway of the LTT screwdriver, available
August 28th.
at lttstore.com. I'm gonna go ahead and get our fans installed. Bykski included 3 of their RGB fans that spin at 3,000 RPM that they claim can do up to 101 CFM. I find that a little hard to believe, but they probably move some air, which is pretty much all we need. I'm gonna go pull configuration. Yep, just like that. No, a pull configuration makes it much easier to clean any dust that accumulates on my radiator fins. But a push configuration is gonna look a little bit nicer inside the case and is gonna move these fittings up a little bit, relatively speaking, which is gonna make this run down to our reservoir a little bit easier. Here's a pro tip, by the way. You wanna put these fittings on before you mount your last fan. It just makes it a little bit easier to get in there. We've got a plan. I'm gonna be using right angle fittings here and here, which conveniently were included. And also convenient is that Bykski included a lot of tubing, enough for you to outright screw up probably about 30% of it before you're really in trouble. So let's start with an easy run and then see how it goes from there, all right? Eyeballing this, it looks like it lines up pretty darn well. So easy way to kind of mark this is we go about an inch past this fitting, and then this is about where we want to do our bend. Just remember, you don't want to just stick it on the heat. You gotta flambe, okay? Note that I'm turning it. It's kind of hard for you guys to see that. And I don't want to just heat up one spot. I'm gonna go about this wide. And go. Oh, borderline, borderline. Wasn't quite enough, but we can recover this. Now what we're gonna do is we're gonna overbend it from 90, and then as it starts to harden, we're gonna let it relax into a 90 degrees. Now what we're gonna do is we're gonna get a little closer. Okay, so we're gonna go to right around there. The key here is to go slow. Be willing to take like a blade's width off at a time in order to make sure you get the length right, because you can always cut off more. You can never uncut. That looks pretty darn good. What we're gonna do now is just clean up these ends a little bit. I wasn't familiar with these until recently, but Bykski has these nice little sleeves that go inside the collars that keep the collars from beating up the tubing as you're screwing it on. So actually quite nice. So we're gonna go ahead and throw that on. Come on. There we go. All right, one run done. Well, hopefully I can still fit an Allen key in here. I can. Excellent, excellent. Here's a tip you won't find in any manual. I could put this tube on right now and it would be straight. But what I'm actually gonna do is I'm gonna take like another 1.5 millimeters off of this one, and then I'm gonna crank this on nice and tight, and I'm gonna use it to help keep my GPU up a little bit. I'm not sure if Bykski got lucky here or if they intended this because AMD has a standard position for their AM5 sockets or something, but look at that, it's perfect. Look how that lined up like that. This looks great. This is where things get hard. If I had any fittings I wanted, I would just avoid doing this because it's a pain in the butt. But we don't. So this is gonna be a 2-bend tube. I'm gonna do one bend up to the GPU and another bend over to my reservoir. For this double bend piece, I've got this length mostly nailed down. It's not quite there, a couple more millimeters need to come off, but I'm not gonna fine tune that until I can actually get it in here and really see what I'm doing. And I can't do that until I make my second bend. So what I'm gonna do is I'm gonna hold it pretty much where it goes, and then I'm gonna find what is gonna be the apex of my bend here. Now, because I don't wanna put a Sharpie mark on my tubing in exactly the right spot, what I'm gonna do instead is I'm actually gonna put a mark on this thing. Then I'm gonna insert it until that mark is in exactly the spot where I want the peak of my bend. That's gonna help me keep track. I didn't quite nail exactly where I wanted it, and it left a frickin' mark inside. Wait, it cracked, it's acrylic. All right, well, don't mark it like that. It's okay, these things happen. It's part of the water cooling process. Well, it's not perfect, but if you don't look too close, I think it fits. Not bad, actually. Yeah, all right. How you doing on this last one here? Hey, not freaking bad. Actually, if I give it a little twist, just like that, it snugs this up a little bit and straightens this out. Now is the moment of truth. What are the odds that this thing just fires up? Anyone? Bueller?
10.
10. We're there, and we had one whole tube left over. I had one more attempt at this potentially. Okay. Pancrats, you wanna plug it in? I say just hit it. Oi! No, we're good, we're good. Dang. Hold on. No, we got a leak. And, oh, there it goes. Well, it's not really the recommended way to do this, but it's possible that this tubing got warped to not completely round when I bent it. Another possibility is that I didn't deburr it. As for that one up there, that one's a little bit more troubling. We'll figure that out though. One moment, please. And we're done and in game. Turns out it was a combination of problems. I didn't tighten this fitting at the top enough. That's on me. But this one down here, that one's on Bykski. Classic Bykski. As it turns out, it turns out that on Bykski's own reservoir, there's not enough clearance to tighten this outer collar down enough to compress the seal. So we had to replace this fitting with a third-party one. Not very beginner friendly. But you still can't fault the result. This looks freaking incredible, and even costing a bit more than back when we bought it, and even with expensive shipping, it offers an outstanding value for something that has mostly parts that I should be able to carry forward to a future upgrade. AMD has committed to supporting the AM5 socket until 2029, so I can keep using that block. Pumps and reservoirs and radiators don't go bad, so realistically, if I upgraded my machine, I'd probably only need a new GPU block for the next cycle. Pretty freaking cool. And by cool, I mean cool. Check this out. I'm sitting at a chilly mid 60 degrees on my CPU, sometimes even lower, and a frosty sub 50 on my GPU. That's expected because while a GPU has a large die that is directly exposed to our copper cooler, CPU has an integrated heat spreader sitting over top of it and much denser heat generating components, so it's a little bit harder to keep them cool. Still, this is more than cool enough for it to operate not only very well, but very quietly. And we could even go quieter. Bykski includes a little remote here that confused us, to say the least. It offers, different RGB controls, which is nice. Ha! So convenient. It controls the whole room, so that's neat. And it allows me to turn my fans up and down. Let's go turbo mode. Where it got confusing was when we tried to turn it to mainboard mode. Okay, so that lets the PWM header on our motherboard control the fan speeds, and it turned all the lights off. Not sure what's up with that. Whoa, buddy, chill. Okay, we're using a little bit of super resolution, transformer model, but we're running it all high, ultra ray tracing, 4K. So pretty great, pretty quiet experience. Not bad for a 4070 Ti. And right, there's another benefit I haven't even mentioned. See how we've got these rock solid temperatures? That results in rock solid clock speeds, which means you're much less likely to get random disruptions or stutters while you're gaming. Before you ask, we did do a full system stress test with Furmark and Cinebench and found that while our CPU did get a little bit hotter, our GPU actually landed right around these same temps, which tells us that this triple radiator is adequate to handle both our CPU and GPU without the water getting too hot, just like I'm enough to handle. This segue to our sponsor.
Meter. At an enterprise level, networks are all too often being managed and maintained by a surprisingly small team. And when they are being pulled in different directions by multiple vendors, each with their own incentives, things get messy fast. Meter can help with that. They operate with modern networking demands in mind. They offer full stack infrastructure for internet, wired, wireless, and cellular networks, all built to scale. Since they design, deploy, and manage the network for you, your team doesn't have to get pulled apart to fix problems. Everyone can focus on more pertinent tasks. There's no high-risk rip and replace needed. Your team gets upgrade credits and migration assistance. Meter offers 24/7 support, and they stay transparent with their pricing. Thanks to Meter for sponsoring this video. Go to meter.com/LTT to book a demo now. That's meter.com/LTT to book a demo.
If you guys enjoyed this video, why not check out the last time we tackled a beginner-friendly, easy water cooling setup? It wasn't easy.